In a previous video, we shared the incredible world-changing news from Japan. A drug that could allow the human body to regrow its own teeth, potentially making dental implants a thing of the past. The excitement from that discovery is real, and the human trials are underway. But what if I told you that's just one piece of a much larger puzzle? What if I told you that the global race to end tooth loss is being fought on multiple extraordinary fronts? All around the world, in different labs, brilliant scientists are exploring other, equally revolutionary methods to regenerate teeth, using everything from lasers to stem cells. Today, we are going beyond the Japanese breakthrough. We are going to explore the next steps in tooth regeneration. We will look at 3 other incredible scientific approaches that could also lead to a future without dental implants. We will also take an honest look at the real-world challenges that still need to be overcome. This is the complete picture of how we will conquer tooth loss. A quick update: the USAG1 antibody trial. Before we explore the other frontiers, let's quickly recap the foundation. The groundbreaking research from Dr. Katsu Takahashi's team in Japan focuses on an antibody that blocks a single protein called USAG1. This protein acts as a natural brake pedal on tooth development. By blocking it, the drug essentially releases the brakes, allowing dormant tooth buds that already exist in our jaws to awaken and grow into a third set of teeth. As we discussed, the Phase 1 human trials began in September 2024 to confirm the drug's safety in healthy adults. The latest updates suggest these trials are proceeding without any major safety concerns, which is a fantastic sign. The team is now moving into Phase 2, which will focus on efficacy, proving that the tooth regrowth seen in animal studies can be replicated in humans. The initial focus remains on patients with congenital anodontia, people born without teeth. But the successful progression keeps the hope alive for a wider application for all of us by the year 2030. This approach is powerful, but it's not the only horse in the race. The other frontiers of tooth regeneration. Now, let's explore the other incredible avenues of research that could also lead to tooth regeneration. Frontier number 1. The stem cell approach, growing a tooth seed. This approach is perhaps the most intuitive form of regenerative medicine. It's based on a simple idea. If we can find the right kind of stem cells, can we grow a brand new tooth from scratch? The answer, scientists are discovering, is yes. Deep inside your healthy teeth, in the soft, pulpy center, are powerful cells called dental pulp stem cells, DPSCs. These are adult stem cells that have the remarkable ability to differentiate into all the different cell types needed to form a tooth: dentin, enamel, cementum, and pulp. Researchers, particularly at institutions like Columbia University and King's College London, are working on a fascinating process. They can harvest these stem cells from a patient's own healthy tooth, like a wisdom tooth that's been extracted. In the lab, they then coax these cells using a cocktail of growth factors to form a tiny bioengineered structure called a tooth germ or a tooth seed. This is essentially the very beginning of a tooth, in its embryonic state. The next step is the truly futuristic part. The idea is to take this tiny, lab-grown tooth germ and implant it directly into the empty socket in the patient's jawbone. The patient's own body would then provide the blood supply and the signals needed for this seed to grow and erupt into a fully functional, natural tooth. A 2019 study published in the Journal of Dental Research successfully demonstrated this process in rats, where they were able to grow bioengineered teeth that were structurally and functionally similar to natural ones. The major challenge now is perfecting this technique for humans and ensuring that the new tooth erupts in the correct alignment and size. Frontier number 2, the laser approach, waking up your own stem cells. What if, instead of growing a tooth in a lab, we could simply tell the stem cells already inside your jaw to start building a new one? This is the incredible promise of a field called photobiomodulation, using low-level lasers. This is not a science fiction laser that cuts or burns. It's a very low-power, non-invasive light that can penetrate into your tissues and have a biological effect on your cells. Researchers at Harvard's Weiss Institute made a groundbreaking discovery. They found that by applying a low-level laser to the exposed pulp of a tooth, they could stimulate the dental stem cells that reside there. The laser light essentially wakes up these sleeping stem cells and triggers them to start forming dentin, the hard tissue that makes up the bulk of a tooth. In their initial animal studies, they were able to regenerate enough dentin to repair large cavities, effectively healing the tooth from the inside out. The ultimate goal of this research is to see if this same technique could be used to regenerate an entire tooth. The theory is that the empty tooth socket, after a tooth is lost, still contains a reservoir of these powerful stem cells. By applying a precisely targeted low-level laser, it might be possible to awaken these cells and provide them with the signal to begin the process of forming a new tooth germ, right where the old one was. This approach is particularly exciting because it's non-invasive, uses the body's own existing cells, and could potentially be a much faster and more affordable procedure. The human trials for this are still in the early stages, but it represents a completely different and very promising path to the same goal. Frontier number 3, the biomaterial scaffold approach, building the blueprint. Our third frontier is an amazing fusion of biology and engineering. One of the biggest challenges in regenerating a complex organ like a tooth is ensuring it grows in the correct shape, size, and orientation. This approach aims to solve that problem by providing the body with a perfect blueprint. Researchers are using advanced 3D printing technology to create a biomaterial scaffold that is an exact, anatomically correct replica of the root of the tooth that was lost. This scaffold is made from a special, biodegradable material, often infused with a cocktail of powerful growth factors. It is then surgically implanted into the empty tooth socket. This scaffold does two amazing things. First, it acts as a perfect blueprint, guiding the body's own cells to grow in the correct shape. Second, the growth factors infused into the scaffold send out powerful signals that attract the patient's own stem cells from the surrounding jawbone to the site. These stem cells then populate the scaffold and begin the process of differentiating and forming the different layers of the new tooth. Over a period of several months, the scaffold itself slowly and harmlessly dissolves away, leaving behind a brand new, natural tooth root that has grown in its place. A study published in the journal Tissue Engineering showed incredible success with this method in animal models, demonstrating the growth of correctly shaped roots that were fully integrated with the jawbone. The next major step is to refine the process to also regenerate the crown of the tooth, but the foundation has been laid. The hurdles and the future, a realistic view. Now, after all this exciting news, it's important to take a deep breath and have an honest look at the real-world challenges. While the science is incredibly promising, the journey from these successful lab experiments to a routine procedure at your local dental office is a long one. The first major hurdle is precision and complexity. A tooth is not just a simple peg. It has a complex shape, a specific alignment with other teeth, and a vital internal network of nerves and blood vessels. Ensuring that a regenerated tooth grows to the exact right size and shape, and that it integrates perfectly with the bite and the nervous system, is an immense scientific challenge. The second hurdle is regulation and safety. Before any of these treatments can become widely available, they must go through years of rigorous human clinical trials to prove that they are not only effective, but more importantly, 100% safe. The risk of unintended consequences, such as abnormal cell growth, is something that must be completely eliminated, and this process, rightfully, takes a very long time. And finally, there is the question of cost and accessibility. While the goal is to create a more affordable alternative to implants, these cutting-edge regenerative therapies will likely be very expensive at first. Making them accessible and affordable for the billions of people who need them will be a major challenge for the global healthcare system. So, while the Japanese anti-USAG1 drug is leading the race and is closest to the finish line, it is clear that we are entering a golden age of regenerative dentistry. The brilliant minds of scientists around the world are attacking the problem of tooth loss from every possible angle. The future of dentistry is no longer just about drilling and filling. It is about healing and regenerating. The end of dental implants as we know them may not be here tomorrow, but for the first time in human history, it is no longer a question of if, but a question of when. The idea that our own bodies hold the key to this incredible act of renewal is a powerful message of hope. Thank you for joining me on this exploration of the future of dentistry. If you found this information as fascinating as I do, please hit that like button, subscribe for more updates on the future of health, and share this video with someone who needs to hear this message of hope. And now, I want to hear from you. Which of these new approaches to regrowing teeth, stem cells, lasers, or scaffolds excites you the most? Share your thoughts in the comments below.